So in this video, today we are going to see about the assist devices in unit 3. So what are the assist devices? There is a cardiac pacemakers, DC defibrillator, dialyzer, then heart lung machine. So these are all called as a assist devices which helps to live with some other sources. So this is called a assist devices. So first of all we are going to see about the functions of heart, because cardiac pacemaker, cardiac means the heart. Okay, so in heart the cardiac pacemakers, we are going to see about the cardiac pacemaker. So first of all, uh, pacemaker. So what is pacemaker and why we are go for pacemaker? So let us see the function of heart. Okay, the heart is a pump made up of a muscle tissue. The heart's pumping action is regulated by an electrical conduction system that coordinates the contraction of various chambers of the heart. So that is the heart. Okay, so generally what is meant by cardiac pacemaker? So generally SA node is responsible for starting of heartbeat, hence it is termed as natural pacemaker. A pacemaker is an electronic device approximately the size of a pocket watch that senses intrinsic heart rhythms and provides electrical stimulation when indicated. Cardiac pacemaker is a medical device which provides support to the phase generating system of heart in case of inadequate functioning of heart phase generating system. A device capable of generating artificial pacing impulses and delivering them to heart. It consists of pulse generator and electrodes. Okay, so this is a cardiac pacemaker. So cardiac pacemaker is that is incorporated in that is it is implanted in externally and internally, depends upon the problem. Okay, so normal electrical activity of heart. So why we go for pacemaker? So first of all we have to understand how the electrical activity of heart. So first initially sinusoidal node, then AV node, bundle of those node, then bundle branches, then Purkinje fibers. Okay, so this is the normal conductive system of the heart. So this is the SA node. Okay, so SA node, AV node, then right atrium, right ventricles here. This is those left bundles of his, then left ventricle, then left atrium. Okay, so this is the Purkinje fibers. Okay, this is the structure involved in the conduction of electrical stimuli through the heart. Okay, why we need it? Whenever this SA node, AV node are not able to generate sufficient pace, in that condition we require pacemaker. Okay, so why we need it? Whenever SA node, AV node are not able to generate sufficient phase, that condition we require pacemaker. Okay, it is otherwise called as the failure of electrical stimulus system. Okay, so failure of electrical stimulus system. So under some abnormalities the natural stimulus mechanism of heart fails. Okay, heart fails continuously or intermittently or insufficient amplitude. This condition is called arrhythmia. Okay, so arrhythmia occurs when heart nature pacemaker develops an abnormal rate or rhythm. The normal conduction pathway is interrupted. Another part of heart takes over as a pacemaker. Okay, what are the symptoms of arrhythmia? Weakness, fatigue, palpitations, low blood pressure, dizziness, fainting. Okay, so what are the clinical indication? So clinical indication is bradycardia and heart block. Okay, so what is a bradycardia? So whenever the heartbeat, that is a heart pulse pumps is not a normal condition, so that is called bradycardia. When once if it is in more number of beats per minute or less number of beats per minute. Okay, normally our heartbeat rates from 70 to 100 beats per second. Whenever it increases or decreases, it is called bradycardia. So bradycardia problem also cured or rectified through this pacemaker. Okay, so these are the types of pacemaker. So one is internal pacemaker, then another one is external pacemaker. So this is a external pacemaker. The pacemaker device is connected outside the body, that is like mobile phones which is kept inside the pocket. So this is external. So this is the internal pacemaker which is inside the body. Okay, so first of all see internal pacemaker. Okay, so internal pacemaker is one which the electrode into the heart, which the electrodes into the heart, the electronic circuitry and the power supply are implanted within the body. Pacemaker which need to be implanted for long time and the patient is suffering from chronic phase generation problem. Okay, it is placed inside the body. It may be permanently implanted on the patients whose SA nodes are failed to function or those who suffered from permanent heart block. Internal pacemaker systems are implanted with the pulse generator placed in a surgically developed pocket below the right or left clavicle in left subcostal region. In case of woman, it is placed beneath the left or right major pectoral muscle. Internal leads are connected to the electrodes that directly contact the surface of myocardium. Okay, so this is the position where the pacemaker is placed in inside the human body. That is internal pacemaker. Okay, so this is a pectoral muscles. So pectoralis major muscle lies in front of chest wall. The inner or medial tendon of the muscle originates from surface of breastbone and collarbone. Okay, the latter or outer end of the muscle continues as lateral tendon and attaches to humerus. So internal pacemaker, the exact location of pulse generator is used in the internal pacemaker system depends on following factors: type and nature of the electrode used, nature of the cardiac problems, mode of operation of the pacemaker system. There is no external connection for applying power, so the pulse generator should be completely self-contained with a battery, which is capable of operating continuously for a specific period. So this is a internal pacemaker. Okay, so there is a internal pacemaker. What is the difference between internal pacemaker and external pacemaker? Means internal pacemaker is a miniature device which is surgically implanted near the abdomen. It requires open heart surgery. Okay, then inside the body, that is internal stimulation. Okay, current in the range of 2 to 15 milliamps is applied. That is internal stimulation is generated by the internal pacemaker. Okay, then external pacemaker, it is applied on patient for short duration externally. So this is the external pacemaker which is placed here in this picture. So next, it consists of an externally placed pulse generator circuit connected to the electrodes placed on the myocardium. Temporary heart irregularities or disorders, treating the patient from arrhythmias, treatment of coronary patient and during the cardiac surgery. It consists of pulse generators. They are placed on the body and connected normally to the electrode with the help of wires introduced into the right ventricle. The pulse generator may be strapped to the lower arm of the patient. So, what are the components a pacemaker? That is electrodes, power source, pulse generator, timing control, output driver, sensing amplifier. Okay, so this is the general block diagram of pacemaker. So power source, timing control, output driver, electrodes, sense amplifier. So sense amplifier is a essential part in the pacemaker which senses whenever the pulse is required for normal operation in the heart. So sense amplifier is a yes necessary, that is a important part of pacemaker. Okay, so pacemaker design, pulse generator leads. So what are the pulse generator in permanent pacemaker is encapsulated in a metal can to protect the generator from electromagnetic interference. So this is a pulse generator. Then this is another type of pulse generator, temporary pacing system. Generator is externally contained in a small box. Okay, so this is the types of pacing modes. Pacing modes: competitive mode, non-competitive mode. In competitive mode, asynchronous mode. In non-competitive mode, ventricular programmed, then arterial programmed. In ventricular programmed, demand mode, standby mode. In arterial programmed, synchronous mode. So already we have studied in electrical activity of heart, ECG. In ECG, QRS complex is essential. So based on QRS complex, the physician or doctors diagnose what is the problem in heart. So this is the R wave inhibited, R wave triggered, P wave. So these are the major part. That is demand mode, standby mode, then synchronous mode. Yeah, by using this kind of modes, we compensate the R wave triggered, then P wave. Okay, so pacing mode and pulse generator. Several pacing techniques are possible with both the internal and external pacemakers. They can be classified as either competitive and non-competitive pacing modes. Competitive, the first and simplest pulse generator or fixed rate or asynchronous device that produces pulses at a fixed rate set by the physician and were independent of any cardiac activity. Phasing modes and pulse generators. Asynchronous phasing is called competitive phasing because the fixed rate impulses may occur along with natural phasing impulses generated by the heart and would therefore be in competition with them in controlling the heartbeat. The competition is largely eliminated through use of ventricular and arterial programmed pulse generator. Non-competitive. So what is non-competitive? Non-competitive uses pulse generators that are either ventricular programmed or arteria programmed. Ventricular programmed pacemakers are designed to operate either in demand or standby. Okay, that is for R wave inhibited. Arterial program phasers are always synchronized with the P wave of ECG. So, what is the types of mode? That is fixed rate pacemaker, ventricular synchronous pacemaker, ventricular inhibited pacemaker. That is always called as or also called as demand pacemaker. Arterial synchronous pacemaker, arterial sequential ventricular inhibited pacemakers. Okay. In fixed rate pacemaker, fixed rate phasers are installed in patients whose SA nodes cannot provide proper pacing impulses. Fixed rate pacers are used temporarily to determine amplitude of impulses needed to pace or capture the heartbeat. The amplitude at which capture occurs is referred to as a pacing threshold. Fixed rate pacemakers fail frequently due to their minimum life of battery. It consists of square wave generator and a monostable multivibrator circuit. It can be implemented in atrium or ventricle. Okay, this is the general circuit. Here it is a monostable multivibrator circuit, and this is a square wave generator. Okay, square wave generator, screaming trigger. So this generates the pulses in the heart. Okay, the period of square wave generator is given by T equal to 2 into RC ln of R3 by 2 R2 plus R3. Okay, so pulse duration is given by TD equal to 5 C of R5 R6 by R5 plus R6. Okay, so TD time delay. Then what are the disadvantages of a pacemaker? Heartbeat rate cannot be changed. If it is fixed in atrium beat at fixed rate. If a ventricle beat at different rate, and then it leads to several severe problems. Ventricular fibrillation may be occurred. Ventricular fibrillation is life-threatening. Ventricular fibrillation is the most serious cardiac rhythm disturbance. The heart cures instead of pumping due to disorganized electrical activity in the ventricles. It is a type of cardiac arrhythmia. The heart can't pump any blood, causing cardiac arrest. This is the main disadvantages of those pacemakers. Okay, so ventricular synchronous pacemaker, the suitable for patients who are suffered by short period of AV node. If ventricular contractions are absent, then the pacemaker provides the impulses. This type of pacemaker does not compare with the normal heart activity. Electrode placed in the right ventricle of heart. This electrode is used to sense the R wave. R wave is the PQRST waveform triggers this pacemaker. This is the general block diagram of ventricular synchronous pacemaker, that is standby pacemaker. So amplifier, filter, timing circuit, fixed rate pacemaker, then output amplifier. Through this output amplifier, the impulse gets generated on the heart. Okay, so electrode is used to detect the heart rate, and it is given to the amplifier and the filter circuit. Because heart rate amplitude is very low, amplifier is used to amplify the cardiac signal. Filter is used to remove unwanted noise signal. High pass filter with FC equal to 20 Hz is used. So P wave is completely eliminated. Then the signal is given to refractory period control and timing circuit. If the heartbeat is normal, then refractory period control and timing circuit will not turn on. Fixed rate pacemaker. Okay, if heartbeat is normal, then refractory period control and timing circuit will not turn on the fixed rate pacemaker. If the detected heart rate is below the certain level, fixed rate for pacemaker is turned on. Whenever R wave is below the certain level, at that time only this pacemaker will deliver the pulses. So, what is the advantages and disadvantages of this type? Advantage: ventricular fibrillation is avoided. When R wave is normal, then fixed rate pacemaker block is not in on condition. So power consumption is reduced. What are the disadvantages? Very sensitive to electromagnetic interferences. Electromagnetic interference can be generated by microwave oven, metal detectors, etc. In model pacemakers, LPF, that is low pass filter, is used to overcome the problem. No synchronization between arterial and ventricular contraction. So next type, ventricular inhibited pacemaker. This is also known as demand pacemaker. The timing circuit consists of a RC network, a reference voltage source, and a comparator. Comparator determines the phasing rate of the pulse generator. Output is given to second RC network. The pulse width circuit determines the duration of the stimulating pulses. The third RC network, which is called as rate limiting circuit, disables the comparator for a short interval and limits the phasing rate. Output circuit provides a voltage pulse to stimulate the heart. Next, this is the ventricular inhibited pacemaker. So here the output circuit unit voltage monitor, which monitors the voltage. This is a rate flow slow down circuit. This is energy compensation circuit. In all the blocks, the tank circuits and the RC circuits has been used. Here the timing circuit, then reversion circuit, sensing circuit, pulse width circuit. Both in all the schemes, the multivibrators and schemic triggers were used. Then refractory circuit, then rate limit circuit, then output circuit. Okay, so refractory circuit and rate limit circuit, which determines the demand. Okay, which is responsible for the demand. So that's why we are calling it as a demand pacemaker. So next, the voltage monitor circuit senses the cell depletion and controls the rate slowdown circuit and energy compensation circuit. Okay, here then rate limit circuit. This rate limit circuit block, that is shuts off some current to the basic timing to slow down the pulse rate during cell depletion. Then energy compensation circuit. This one, okay, this one which causes the pulse duration unit to increase the battery voltage when it decreases, and it is used to supply the energy to the heart. Okay, so the feedback loop from the output circuit to refractory circuit provides a timing period following an output pulse. Sensing circuit detects a spontaneous R wave and resets the oscillator timing capacitor. In the absence of R wave, the circuit allows the oscillator to produce pacing pulses at its present rate. So hence it is termed as, that is, if the R wave is missing for a preset period of time, then the pacemaker will turn on and provide the heart as stimulus. Hence it is termed as a demand pacemaker. Okay, so then next one, arterial synchronous pacemaker. So here amplifier, delay circuit, refractory control, preset multivibrator, output amplifier has been used. P wave is sensed. Here in arterial synchronous pacemaker, P wave is sensed and picked up by the electrode fixed on the atrium. It is given to the amplifier circuit. Amplifier circuit is used to amplify the P waveform. Then it is given to delay circuit. Delay circuit is used to give the delay 0.12 second. Output of the delay circuit is given to refractory control and preset multivibrator block. Okay. In arterial synchronous pacemaker, if the P wave amplitude is not in normal value, then fixed rate pacemaker will turn on. When P wave amplitude is normal, then fixed rate pacemaker is off. If fixed rate pacemaker is on, then the output is given to amplifier. The amplified signal is given to ventricle through electrode. Refractory control circuit provide some time delay because pacemaker pulse is too large. Okay, so always the refractory control circuit provides some time delay because pacemaker pulse is too large. Okay, then the atrial sequential ventricular inhibited pacemaker, it is used both arterial and ventricle stimulations. It is a demand pacemaker, so based on the patient's need, it provides the impulses. In the modern pacemakers, magnet is placed over the pacemaker on the skin of the patient. This magnet is used to activate the reed switch. This switch switches the pacemaker into any one of the mode of operation, either to give the impulse for atrial or to ventricle. Okay, so these are all the types of pacemakers, so which is responsible to generate the impulses. Okay, so what are the types? One is fixed rate pacemaker, then ventricular synchronous pacemaker, ventricular inhibited pacemaker, which is also known as a demand pacemaker, atrial synchronous pacemaker, then atrial sequential ventricular inhibited pacemaker, that is also called as a demand pacemaker. So refractory circuit, then timing control circuit is the most essential part in the pacemakers. Okay, then we go for a defibrillators. Okay, so defibrillators. So what is defibrillation? Before that, we have to understand what is fibrillation. So the heart is able to perform its important pumping function only through precisely synchronized action of the heart muscle fibers. The rapid spread of action potentials over the surface of atria causes these two chambers of the heart to contract together and pump blood through the two atrioventricular valves into ventricles. After a critical time delay, the powerful ventricle muscles are synchronously activated to pump blood through the pulmonary and systematic circulatory systems. A condition in which this necessary synchronization is lost, is known as a fibrillation. So during fibrillation, the normal rhythmic contraction of either artery or the ventricles are replaced by rapid irregular twitching of muscular wall. Fibrillation of atrial muscles is called atrial fibrillation. Fibrillation of ventricle muscles is called ventricular fibrillation. Okay, so this is the fibrillation condition, normal sinus rhythm, atrial fibrillation. Okay, so what is meant by defibrillation? Defibrillation causes the heart to stop pumping blood, leading to brain damage. Defibrillator deliver a brief electric shock to the heart, which enables the heart's natural pacemaker to regain control and establish a normal heart rhythm. So defibrillators deliver a brief electric shock to the heart, which enables the heart's natural pacemaker to regain control and establish a normal heart rhythm. So defibrillation is a process in which an electronic device sends an electric shock to the heart to stop an extremely rapid, irregular heartbeat and restore the normal heart rhythm. So this is the defibrillator circuit. So this is the defibrillation process which are giving for a patient. So this is a paddle. This is called a paddle. Then this is a switching control. Okay, so this is a switch control. So this is a very important, because whenever we are pressing, then only the voltage supplies. Otherwise the paddle is in idle state, there is no voltage supply. Okay, so purpose. So what is the purpose of defibrillation? Defibrillation is performed to correct life threatening fibrillations of the heart, which could result in cardiac arrest. It should be performed immediately after identifying that the patient is experiencing a cardiac emergency, has no pulse, and is unresponsive. So, what are the precautions? The paddles used in procedure should not be placed on a woman's breasts or over a pacemaker. Defibrillation should not be performed on a patient who has a pulse or is alert, as this could you cause a lethal heart rhythm disturbance or cardiac arrest. So, what are the types of defibrillator? AC defibrillator, DC defibrillator, dual peak, synchronized DC defibrillators are the four categorized types in defibrillation. In AC defibrillation, that is burst of 60 hertz AC at intensity of 6 amps has been uh, given. If the patient does not respond, the burst is repeated until defibrillation occurs. This method is known as a AC defibrillation. Okay, so this is the AC defibrillation circuit. In both the primary windings and the secondary windings has been used. Transformer is used to increase the power supply to the chest electrodes. Okay, so this is the general circuit of AC defibrillator. So what are the disadvantages of AC defibrillator? It cannot be successfully used to correct atrial defibrillation. Successive attempts to correct ventricular fibrillation are often required. Attempts to correct atrial fibrillation by this method often result more serious ventricular fibrillation. Okay, so these are the disadvantages of using AC defibrillator. Then we go for DC defibrillation. To overcome the disadvantages of defibrillation method, Bernard Law from Harvard School of Public Health and Peter Bent of Brigham Hospital developed a new method called DC defibrillation. DC defibrillation, capacitors charged to a high DC voltage and then rapidly discharged through electrodes across the chest of patient. DC defibrillation is capable of correcting both the atrial fibrillation and ventricular fibrillation. DC method produces some harm to the patients. Depending on the energy setting in the defibrillator, the amount of electrical energy discharged by capacitor ranges from 100 to 400 joules. Discharge portion is approximately 5 milliseconds. In discharge waveform, the peak value of current is nearly 20 amps and the wave is monophasic in nature. Monophasic means most of the exertion of curve is above the baseline. So this is the DC defibrillation circuit. Okay, so this is the defibrillation circuit. Then here the this capacitors, this capacitor is charged up to high voltage. Then this capacitor discharges to give a necessary defibrillation to the patients. Okay, so dual peak DC defibrillator. The another type is DC dual peak DC defibrillator. If peak voltage is a high as 6000 volt is used, there is a possibility of damaging myocardium and the chest walls. Produce dual peak waveform of longer duration at lower voltage. Effective defibrillation is achieved in adults with low level of delivered energy. Energy range is between 550 to 200 watts per second or joules. Okay, the amplitude of the waveform is relatively constant but is varied to get required energy. Large electrodes are used for power proper delivery of large current through the surface of the skin. These electrodes are called as a paddles. Okay, so this is a dual peak DC defibrillator. So synchronized DC defibrillator. Synchronization means synchronized the working of heart with the pacemaker. Synchronized DC defibrillator allows the electric shock at right point on the ECG of the patient. Electric shock is delivered approximately 20 to 30 milliseconds after the peak of R wave of patient's ECG. So this is the synchronized DC defibrillator. In this, ECG amplifier has been used, then time delay circuit, then defibrillator circuit. It is the general block diagram of synchronized DC defibrillator. So synchronized DC defibrillator ECG waveform is traced from the patient. R wave in the output of ECG amplifier triggers the time delay circuit. It gives the delay of 30 milliseconds approximately. After that, defibrillator circuit is switched on so that the capacitor discharges. So that the capacitor discharges the electric shock to the patient's heart. The moment at which electric shock occurs is noted by producing the marker pulse on monitoring display. This type of circuit is preferred as cardiac emergencies. The sudden cardiac arrest can be treated using defibrillator, and 80% of patients will be cured from the cardiac arrest if this is given within 1 minute of the attack. That is a synchronizer DC defibrillator. So, what are the electrodes used for defibrillation? That is called paddle. These paddles have metal discs of 8 to 10 centimeter in diameter for external use. For internal use, smaller paddles are used on infants and children. For external use, pair of electrodes are firmly pressed against the patient's chest. Conductive gel or saline soaked gauze pad is applied between each paddle surface and the skin. Okay, what is the need of insulation handle to prevent the person applying the electrodes from accidental electric shock? Specially insulated handles are provided in the paddles. When the paddles are properly positioned, this prevents the patients from receiving a shock. In earlier equipment, foot switch is used instead of thumb switch. So, what is the need of thumb switch? There is a possibility of someone accidentally stepping on the foot switch in the excitement of an emergency before the paddles are placed. So, thumb switches are mostly preferred. In some defibrillator, charging is done by means of charge switch located in the front of the panel of the unit. The charge switch is located in the handle of one of its paddles. In few defibrillators, the charging process being automatically after discharge. So, what are the types of electrodes used in defibrillator? That is anterior, posterior. So, anterior paddles are applied to the chest. Anterior, posterior paddles are applied to both the patient's chest wall and back so that the energy is delivered through the heart. This method of paddle application offers better control over arrhythmias that occur due to arterial activity. Specially designed pediatric paddles are available with a diameter ranging from 2 to 6 centimeter. Internal paddles can be either gas sterilized or autoclaved. Okay, then indication meter. The indication meter which indicates the fibrillation rate and what is the and what is the status. What is the status or improvements in the patient's heartbeat. So most of the defibrillators include a watt second per meter to indicate the amount of energy stored in the capacitor before discharge. The energy indicated on the meter is lost or dissipated as a heat in the components inside the unit. So this is the indicator meter. Okay, so this is the indicator meter. So most of the defibrillators include a watt second meter to indicate the amount of energy stored in the capacitor before discharge. The energy indicated on the meter is lost or dissipated as heat in the components inside the unit. Okay, so followed by we have to see about the dialyzer. Okay, so dialyzer is nothing but an artificial kidney. Okay, so dialyzer is nothing but an artificial kidney. That is a purification of the blood. That is the main process. So before that, it is used as an artificial kidney. So we have to know what is the function of kidney. So maintaining acid base balance, form urine out of blood plasma. So two process: one, removal of waste products from blood plasma, then regulation of composition of blood plasma. These are the main functions of a kidney. Then it is responsible for maintaining osmotic pressure, that is pH, etc. of extracellular body fluids. Okay, so this is a urinary system. Then artificial kidney, so this is used in a kidney transplantation. Then dialyzer, artificial kidney. Okay, there is three types of artificial dialysis. That is a transplant, hemodialysis, peritoneal dialysis. Okay, dialysis. So diffusion, osmosis, then ultrafiltration are the three important processes used in dialysis. So that is dialysis is based on principle of diffusion. So diffusion is the movement of solutes from an area of greater concentration to an area of lower concentration. So osmosis is the movement of fluid from an area of lesser concentration to an area of greater concentration of solutes. This is a osmosis. Then ultrafiltration, that is a solution moves when there is an osmotic gradient or pressure gradient across the membrane. So this is a ultrafiltration. Then dialysis. So extracorporeal dialysis, intracorporeal dialysis, that is peritoneal cavity dialysis, then hemodialysis. There is two types of dialysis in the dialysis process. So hemodialysis, peritoneal dialysis. So what is the major difference? So hemo simply means blood. Dialysis meaning to pass through. It removes the nitrogenous waste products, exceeds fluid and electrolyte from the blood by means of artificial kidney. The nearly 90% of all dialysis patients receives hemodialysis. Peritoneal dialysis means it removes nitrogenous waste products, that is excess fluids and electrolytes from the body by means of peritoneal membrane. Approximately 10 to 15% patients are receiving peritoneal dialysis. Okay, so this is a peritoneal dialysis. So hemodialysis, that is blood is taken out from the body and waste products diffused through a semi-permeable membrane, which is continuously rinsed by a dialysing solution. So this is the hemodialysis. So first blood is passed through the dialyzer, that is it is having a osmosis, then ultrafiltration, then diffusion process. Through this, it gets purified and it is again initiated into that is implanted into the body. Okay, so this is the hemodialysis. Here we can see the semi-permeable membrane, blood with the waste products. Then waste product pass through the membrane. The waste product pass through the membrane. Then it gives the pure blood again from the dialyzer machine. So this is the hemodialysis. So hemodialysis machine cleans the blood. Blood and dialysis fluid do not mix. It can up to take up to 3 to 6 hours, usually 3 times per week, either inpatient or outpatient by trained staff. So this is the hemodialysis machine. Okay, so here the blood is given to the dialyzer. The dialyzer does some purification process by passing through some permeable membrane. Then the purified blood is again go through the body. Okay, so this gives some relief to the patients. Then peritoneal dialysis. Peritoneal dialysis, that is peritoneal cavity in our body is used as a semi-permeable membrane, and passing dialysate into it, waste products are removed from the blood by diffusion. Peritoneal dialysis, the installation of dialysis fluid into the peritoneal space via surgically inserted catheter. Most catheters are silicone. Fluid is removed to take out the toxins. So this is the principle of peritoneal dialysis. Okay, peritoneal dialysis. So this is the peritoneal dialysis. So process uses the patient's peritoneum in the abdomen as a membrane across which fluids and distant dissolved substances are exchanged from the blood. Fluid is introduced through a permanent tube in the abdomen and flushed out either every night while the patient sleeps or via regular exchanges throughout the day. Okay, this is a peritoneal dialysis. The fluid used for dialysis uses glucose as a primary osmotic agent, but this may lead to peritonitis, the decline of kidney and peritoneal membrane function, and other negative health outcomes. The acidity, high concentration, and presence of lactate and product of degradation of glucose in the solution may contribute to these health issues. So, what are the major causes? That is, infections may occur. The most common problem for people receiving peritoneal dialysis is peritonitis, an infection of the lining of abdominal cavity. An infection can also develop at the site where the tube is inserted to carry the cleansing fluid into and out of the abdomen. That is, peritoneal dialysis is less efficient at removing waste from the body than hemodialysis, and the presence of tube presents a risk of peritonitis due to the peritoneal to introduce bacteria to the abdomen. A contributing factor for infection in peritoneal dialysis is failure to use aseptic techniques using procedures. So patients should be precisely educated about how to perform peritoneal dialysis at home. Recurrent peritonitis can lead to complications such as peritoneal fibrosis, and peritoneal dialysis cannot be performed any longer. So peritoneal adverse events, peritonitis due to contamination at time of exchange or infection of exit site. loss of access site due to infection and fibrosis, death if a sepsis develops. Okay, if a sepsis develops, the it may cause leads to the death. Okay, so these are all the things we have to learn from a dialysis. Okay, so dialysis unit. So we have seen the dialysis, then defibrillator, pacemaker. So these are all called as a assist devices. Without these devices we can't do, that is we can't live a normal life. Okay, if anything happens to the heart or any fibrillation occurs, the fibrillation means the abnormality in the heartbeats or heart pumping activity. So if any abnormalities in heart pumping activity, then the heart becomes weak, and it may leads to death immediately. So we have to regularize the heartbeat. So we have to regularize the heartbeat. For regularize the heartbeat, some medicines are there. Other than that, pacemaker is the only device that which assist ourselves to live peacefully and as like a normal as person. Okay, then dialysis which is nothing but a artificial kidney. It performs the functions of a kidney to maintain pH level in our body. Then defibrillator. So whenever we having a fibrillation, then we have to place the defibrillation. So defibrillation plays an important part during a medical emergency or cardiac arrest. Whenever the patients in some other stations, it may cause a severe attack, a severe heart attack, or a severe some fading, some fainting due to some fat and cholesterols in our body. So we have to eat healthy food to prevent those things. We have to avoid oil foods and junk foods to prevent from these kind of situations. Okay, so these are called assist devices. So assist devices plays a vital role in our life to save ourselves and leads to a normal life without any complications. So this is a assist devices. Okay, thank you.